this video we're going to be talking about solving rational equations and inequalities using technology. So you will need to be using your graphing calculator for this and taking notes, because as usual the work we do in this lesson will be reflected in our thinking assignments that's coming up later next week. We want to start by looking at a simpler rational equation, and we know it's an equation because we're using the equal sign and not an inequality symbol. So this rational equation is going to have a finite set of answers. There's two ways we can go about doing this when we're solving with technology. We can choose to graph both sides of the equal sign and find the intersection . So we're finding the point or points where these two functions cross. Our other option is to rearrange the equation or the equations so that we have one equation that's equal to 0. Okay, so both of these strategies will allow us to solve these equations and inequalities. I'm going to start example A by working on the graphing calculator and graphing both sides of the equation and finding the intersection. So make sure you've got your calculator loaded up. As usual, you always want to start by resetting the memory. You can see that on my calculator I've got some old work in here, and I don't want that to interfere with my solution. So I've reset my memory, and now I'm going to graph the left-hand side You want to make sure that you're including brackets properly, because otherwise your function is going to graph this using strict bedmaster rules. Let's just take a look at what this function looks like when we graph it. We can see on the graph that the calculator does have some trouble dealing with those asymptotes. Okay, the calculator is actually drawn in the asymptote. The way the calculator works when it's graphing is it's essentially making a table of values. And as it gets to this point here, and it sees then the next value in the table jumping to way up here, the calculator wants to connect those 2 points with a straight line. So there's a little bit of a limitation with our graphing calculator when we're dealing with asymptotes, but if we recognize, if we know that there should be an asymptote around this point, we should realize that this line is just an asymptote. So I've graphed the first function, or I've graphed the left-hand side. I can also graph the right-hand side. The right-hand side is just equal to 4. And there we see my original function, left-hand side, and then the right-hand side with that line at y equals 4. So the command we want to use to find the intersection is the intersection command. We can find that by pressing the second function and then the trace button. We get our calculator commands, and we want to use command number 5 for the intersection. And the calculator is asking us, is this the first curve that you want to find the intersection for? And yes, it is. And all I'm going to do is I'm going to move my crosshairs to the right-hand side of the asymptote, and that's where I can see my intersection being. And I'll hit enter. And then it's asking me, is the line y equal 4 the second curve, and yes it is. And I hit enter one more time. The calculator does its thing. And the calculator tells me that my intersection is at the point 2 and 4. So in my question, I can say that the point of intersection is at the point 2 and 4. Let's do a little bit of a harder example. Here I want to solve this equation. So I want to find out what x value makes the left-hand side equal to the right-hand side. We'll try this by graphing both functions on our calculator. So I'll graph x over x minus 2, and I'll graph 2x squared minus 3x plus 5 all over x squared plus 6. Let's see what this looks like. So this is a little bit harder to see where the intersection is. We'll try this like the previous question, where we find the intersections. So I press second function, trace, and then number 5. And I do want to show you where you might run into some trouble. See where my crosshairs are, nowhere near where the intersection is. And I'll press enter on my first curve. I won't move my crosshairs on my second curve. I'll press enter again. And one more time, the calculator starts thinking about this. You can see the calculator's having some trouble. It's taking a long time. And then I get this error message, no sign change. So the calculator is looking for an intersection around this area where I put my crosshairs. And it doesn't find any. It keeps expanding its search area until it gets to this asymptote, and then it runs into trouble. So when we use the intersection command, we need to make sure we're moving our crosshairs close to where we think the intersection is. And this time, there, I should see that my intersection is at x equals 6.47. So that's how we can do this with technology using the intersection command. We do have another option. We can rearrange this and set our equation equal to 0. And the way we can do that is by multiplying both sides by a common denominator. And our common denominator would be x minus 2 times x squared plus 6. So multiplying both sides by this common denominator, we can do a little bit of canceling. The denominator on the left-hand side cancel with one of these terms. The denominator on the right-hand side will cancel with one of these terms. Which leaves me with something a little bit easier to work with. I have x squared plus 6 times x, and that's equal to x minus 2 times the numerator 2x squared minus 3x plus 5 distributing, I get x cubed plus 6x on the left hand side and 2x cubed minus 3x squared plus 5x minus 4x squared plus 6x minus 10 on the right hand side. And I want to be able to set one side equal to 0, so I'm going to bring everything on the left-hand side over to the right-hand side. So I'll have 2x cubed minus x cubed minus 3x squared minus 4x squared plus 5x minus 6x plus 6x minus 10. And now I just need to gather up my like terms and simplify x cubed minus 7x squared plus 5x minus 10 is what I end up with. And now on the TI-83, I can graph this function. So let's clear what I've been working on previously, and we'll graph x cubed minus 7x squared plus 5x minus 10. I can't see a full picture, so I'm going to zoom my window out a little bit. I'll make this negative 20 to 20. Let's see if that helps. Not really concerned with what's going on down here. All we're trying to find is where this function equals 0. So we're trying to find the zeros, just like in the last unit. So I can use the calc command to find the zeros. I'll move my cursor close to the 0 on the left-hand side and on the right-hand side. And look at that. The calculator's found the same 0 value as we found when we found the intersection previously. So x is approximately equal to 6.47, and we found that two ways. What I'd like you to try is an inequality question. I'd like you to solve this inequality on your graphing calculator. So we're trying to find out when x squared minus x minus 2 all over x squared plus x minus 12 is greater than 0. Sorry, greater than or equal to 0. We will do this in class tomorrow as our opening exercise, but I would like you to try this ahead of time. Do keep in mind that the commands from this video lesson will be the ones that we'll be using on the thinking assignment that's coming up sometime next week. Thanks for watching.